the one thing that's probably causes some of the most pain in chemistry and in organic chemistry in particular is just the notation and the nomenclature, the naming that we use. And what I want to do here in this video and really the next few videos is to just make sure we have a firm grounding in the notation and in the nomenclature or how we name things. And then everything else will hopefully not be too difficult. So just to start off, and this is really a little bit of review of regular chemistry. If I just have a chain of carbons, and organic chemistry is dealing with chains of carbons. So let me just draw a one carbon chain. So it's really kind of ridiculous to call it a chain. But if we have one carbon over here, and it has 4 valence electrons, it wants to get to 8. That's the magic number we learned in just regular chemistry for all molecules. That's the stable valence structure, I guess you could say it. So it would, if it a good partner to bond with is hydrogen, because it has 4 valence electrons. And then hydrogen has 1 valence electron, so they can each share an electron with each other. They can each share an electron with each other. And then they both look pretty happy. I said 8's the magic number for everybody except for hydrogen and helium. Both of them are happy because they are only trying to they're only trying to fill their 1s orbital. So the magic number for those two guys is 2. So all of the hydrogens now feel like they have 2 electrons. The carbon feels like it has 8. Now there's several ways to write this. You could write it just like this, and you can see the electrons explicitly. Or you can draw little lines here. So I could also write this exact molecule, which is methane. And we'll talk a little bit more about why it's called methane later in this video. I can write this exact structure like this. A carbon bonded to 4 hydrogens. Bonded to 4 hydrogens. And the way that I've written these bonds right here, you could imagine that each of these bonds consists of 2 electrons, one from the carbon and one from the hydrogen. Now, let's explore slightly larger chains. So let's say I have a 2-carbon chain. All right, let me do a 3-carbon chain, so it literally looks like a chain. So if I were to draw everything explicitly, it might look like this. So I have a carbon. It has 1, 2, 3, 4 electrons. Maybe I have another carbon here that has, let me do the carbons in slightly different shades of yellow. I have another carbon here that has 1, 2, 3, 4 electrons. And then let me do the other carbon in that first yellow. And then I have another carbon. So we have a 3-carbon chain that has 1, 2, 3, 4 valence electrons. Now, these other guys are unpaired, and if you don't specify it, it's normally going to be hydrogen. So let me draw some hydrogens over here. So you're going to have a hydrogen there, a hydrogen over there, a hydrogen over here, a hydrogen over here, a hydrogen over there, a hydrogen over here. Almost done. Hydrogen there, and then a hydrogen there. Now notice, in this molecular structure that I've drawn, I have 3 carbons. They were each able to form 4 bonds. This guy has bonds with 3 hydrogens and another carbon. This guy has a bond with 2 hydrogens and 2 carbons. This guy has a bond with 3 hydrogens and then this carbon right here. And so this is a completely valid molecular structure, but it was kind of a pain to draw all of these valence electrons here. So what we typically would want to do is at least this structure, and we're going to see later in this video there's even simpler ways to write it. So if we want to at least do it with this kind of these lines, we can draw it like this. So you have a carbon, 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 and then they are bonded to the hydrogens. So you'll almost never see it written like this because this is just kind of crazy. Hydrogen, hydrogen, at least crazy to write. It takes forever. And it might be messy, like it might not be clear where these electrons belong. I didn't write it as clearly as I could. So they have 2 electrons there. They're shared with these 2 guys. Hopefully that was reasonably clear. But if we were to draw it with the lines, it looks just like that. So it's a little bit neater, faster to draw. Same exact idea here and here. And in general, and we'll go in more detail on it, this 3-carbon chain where everything is a single bond is propane. Let me write these words down because it's helpful to get. This is methane. And you're going to see the rhyme, you're going to see the reason to this naming soon enough. This is methane. This is propane. Propane. And there's an even simpler way to write propane. You could write it like this. You could write it like this. You could write it, instead of explicitly drawing these bonds, you could say that this part right here, you could write that part right there, that is CH3. So you have a CH3 connected to this is a CH2, that is CH2, which is then connected to another CH3. And the important thing is, no matter what the notation, as long as you can figure out the exact molecular structure, as long as you can, so there's this last CH3. Whether you have this, this, or this, you know what the molecular structure is. You could draw any one of these given any of the others. Now, there's an even simpler way to write this. You could write it just like this. Let me do it in a different color. You literally could write it, so we have 3 carbons. So 1, 2, 3. And now this seems ridiculously simple, and you're like, how can this thing right here give you the same information as all of these more complicated ways to draw it? Well, in chemistry, and in organic chemistry in particular, any of these, this is called, I think they call it a line diagram or line angle diagram. It's the simplest way, and it's actually probably the most useful way to show chains of carbons or to show organic molecules once they start to get really, really complicated, because then it's a pain to draw all of the H's. But when you see something like this, you assume that the endpoints of any lines have a carbon on it. So if you see something like that, you assume that there's a carbon at that endpoint, a carbon at that endpoint, and a carbon at that endpoint. And then you know that carbon makes 4 bonds. There are no kind of charges here. All of the carbons are going to make 4 bonds. And each of the carbons here, this carbon has 2 bonds. So the other 2 bonds are implicitly going to be with hydrogens. If they don't draw them, you assume that they're going to be with hydrogens. This guy has 1 bond, so the other 3 must be with hydrogen. This guy has 1 bond, so the other 3 must be hydrogens. So just drawing that little line angle thing right there, I actually did convey the exact same information as this depiction, or this depiction. So you're going to see a lot of this. This really simplifies things. And sometimes you see things that are in between. You might see someone draw it like this, where they'll write CH3, and then they'll draw it like that. So that's kind of combining this way of writing the molecule, where you write the CH3s for the endpoints, but then you implicitly have the CH2 on the inside. You assume that this endpoint right here is a C, and it's bonded to 2 hydrogens. So these are all completely valid ways of drawing the molecular structures of these carbon chains or of these organic compounds.